Hari Om. So today we will see topological sorting, one of conventional problems that we have in graphs. The input for the problem is a directed acyclic graph, that is DAG. We need to organize the vertices in the graph such that if there exists a edge UV in the graph and we have the topological ordering of that graph, in that ordering we cannot have V preceding U. That is, we cannot have V in front of U in that ordering. So let us take an example. We do have an edge here at AB. Topological ordering for this graph could be something like S, C, D, A, B, E, or S, A, B, C, D, E. And it cannot be something like S, C, B, A, D, E, because in this ordering we have A after B, but in the graph we have the edge AB. So this is not a proper ordering. Okay, now the solution for this topological sort for a given directed acyclic graph is not unique, in the sense we can have multiple solutions. So let us start working on this graph to arrive at one possible topological ordering. For that we have to make use of the concept of in degree of the given graph. So in degree of the graph or of a vertex in the graph is the number of edges that come towards that vertex. For example, in degree of A is 2, in degree of S is 0, in degree of C is 1. Similarly, in degree of E is 2, and it goes on like this. So how are we going to start with this? We are going to form a table with the vertices in the graph as the rows. So let us start with S, A, B, C, D, and E. And initially at the first iteration, let us note down the vertices in the in degree of the vertices in the graph. In degree of S is 0, in degree of A is 2, in degree of B is 1, in degree of C is 1, in degree of D is 2, in degree of E is 2. Now we are going to use a Q To start with, we are going to NQ the vertices with in degree 0 on during the each iteration. This is going to happen. So when we DQ that vertex, we are going to remove that vertex from the graph by detaching the edges for the adjacent vertices. That is, if S is removed, A and C are the adjacent vertices for S. So the in degrees of A and C will get reduced by 1. So let us NQ S first. So whatever the vertices with in degree 0 are going to be in the Q. So now S is the only vertex with in degree 0. It is NQ'd. On dequeuing this S, so we are going to make use of one more array for our solution. This is going to be S into my solution to start with. So when I dequeue this S from the Q, what are the adjacent vertices to S, A and C? So in degree of A gets reduced by 1 and C gets reduced to 0. The rest of the vertices in degree remain same. So to mark with, we are done with yes, so let us make it mark. So B remains 1, in degree of D remains 2, and in degree of E remains 2. So in this iteration, we are going to check if there are any new vertices within degree 0. Yes, there is one. It is C. So C is NQ'd. Now DQing C will make C into my solution set. So on making C removed from the graph, we have the in degree of D getting reduced to 1 and in degree of A getting reduced to 0. So this in degrees remain the same. Now at the end of this iteration, we are going to check if there are any new vertices with in degree 0. Yes, there is a vertex A. So A is NQ'd. Now DQA, A gets into my solution set. These are the vertices I am done with. Now A is also done. So on taking A, what is the impact on the given graph? Yes, in degree of B gets reduced to 0, in degree of D remains the same, and E remains the same. Now any new vertex that has in degree 0, yes, there is B. So now NQB, no new vertices, no other new vertices. So DQB, B gets into my solution set. On taking B, what happens? In degree of D and E should get reduced by 1. So on reducing in degree of D, it goes to 0. On reducing in degree of E, it becomes 1. So these vertices are done with already. So this is the new vertex. Now we need to check if there is any new vertex with in degree 0. Yes, there is. It is D. So this D is the new one into my Q. On NQ, after DQing this, DD gets into my solution set. On taking D, this impacts the in degree of E to 0. So these vertices are done. This is the new one, and the new vertex here with in degree 0 is E. So this is done. Now this new vertex is DQ'd. No more vertices will be available with new in degree 0. So look at this SCABDE, a valid one. Thank you.